Hello to my wonderful trig class. Here is 4C. Let's learn how to graph tangent and cotangent. Okay, so first you're going to use the unit circle to fill in the tables. Go ahead and pause to do that now. Alright, remember undefined values are vertical asymptotes. So at pi halves, we're going to have a vertical asymptote. And at 0, and at pi. Okay, and then our next points at 0, 0. Pi fourths goes up to 1. 3 pi fourths goes down, negative 1. And pi is at 0. Okay, this is a weird looking graph, but I happen to know what tangent looks like, so I'm going to show you. We connect these two, and we connect these two. Now what you can't see is what's happening as they continue. They're going to go like this, so it should be like this, and like this. Okay, so tangent is a wave. It looks a lot like x cubed. Okay. But what you're required to graph is just this, just the 5 MVPs. Okay, technically that's one full cycle. One wave is a full cycle, and this is the upper part of the wave, and this is the lower part of the wave. Okay, let's graph cotangent. At pi fourths we go up 1, pi halves is 0, 3 pi fourths is negative 1. Okay, and that's going to be a little wave 2. Okay, so let's notice some things about tangent and cotangent when we picture it. So first of all, tangent is always increasing, right? The next point is above the point that was before it. And then it starts over at the vertical asymptote. And again, each point that comes as you increase the x's, the y's get larger as well. Okay, here cotangent is decreasing. It's steadily decreasing. So each vertical asymptote shows that from each vertical asymptote to the next, you're going to have a decreasing wave. Okay, again, this is one full cycle. That means that the period of tangent is not the same, and cotangent is not the same as the period of sine and cosine. Tangent is actually one full cycle occurs in pi units. So the period of tangent is pi. Let's picture it. Tangent, our first point, here is our midline. Our first point is at the midline. The next one is at positive A, whatever your amplitude is. P3 is a vertical asymptote. Then you have negative A, the amplitude below, and back to the midline. This is what tangent looks like. So P1 and P5 are intercepts, and P3 is an asymptote. But for cotangent, P1 and P5 are vertical asymptotes, and P3 is an intercept. Remember that cotangent is steadily decreasing as tangent is steadily increasing. Alright, those are the 5 MVPs for tangent and cotangent. The transformations of tangent and cotangent are very similar to the ones we had for sine and cosine. There are just a few differences. Of course, how the y's go is different. But finding all the other points, the x values, is the same. The period, of course, for tangent is pi. So to find the period, if it's transformed, would be pi over b rather than 2 pi over b. As a reminder, P5, the right endpoint, is equal to P1, your phase shift, plus your period. So C over B plus pi over B. All right, P3 is the average of P1 and P5. P2 is the average of 1 and 3. P4 is the average of 3 and 5. Just like when we did sine and cosine. The only difference is you can vertically shift tangent and cotangent. That is still K, but I'm not going to test you on vertical shifts of tangent and cotangent. And we have two examples. So let's start with this one. Tangent. A is 2 plus or minus 2. That's our, well, it's your amplitude is absolute value of 2, and that's what you're going to go above and below. I like to write it as plus or minus 2 because it's not the maximum and the minimum value. You're still going on beyond that. And so, but it's still the amplitude of the tangent graph. B is equal to 2 and C is negative pi halves. Phase shift is B over C, so negative pi halves, sorry, C over B, negative pi halves over 2 is negative pi fourths. That's P1. As I said before, I'm not going to be testing you on midline shift, so that will just be 0 each time. The rise is plus or minus 2. The period is pi over B, which is 2. So pi halves. All right, to find P5, we take the starting point and we add the period. Pi halves with the denominator of 4 is 2 pi halves. Sorry, 2 pi fourths is 2 over 4 is equal to 1 over 2. So we're going to add 2 pi fourths. That is pi over 4. Okay, if your P1 is negative pi fourths and your P5 is pi fourths, that is centering right around the y-axis, which is really convenient for finding the other points. Okay, halfway between negative pi fourths and pi fourths is 0. Halfway between negative pi fourths and 0, well, that's just half of negative pi fourths. And you'll get that. Negative pi fourths over 2 is negative pi over 8. And this one similarly is going to be positive pi over 8 because it is perfectly reflected. Sorry, it is not reflected. The x values are reflected. The y values are not. Okay, so it's centered around the y-axis. Our amplitude is going to go up 2, down 2, so I'm going to put 3 units because it continues on past that. Left we'll have negative pi fourths, which means that like negative pi halves is over here, just kind of an anchor point, positive pi fourths and positive pi halves. This is negative pi over 8, positive pi over 8. Usually I get the same denominator, but fourths and eighths, I know that eighth is just a half of a fourth, so it's not super complicated to do this one. Okay, but to remember the 5 MVPs of tangent. Whoa, we're going everywhere. Okay, at negative pi fourths, we start off, the y value starts off at the midline for tangent. Starts off at the midline. Tangent starts off at the midline. Okay, now cotangent starts off with an asymptote. It's surrounded by asymptotes. Our asymptote for tangent is directly in the middle. So at negative pi fourths, we have an intercept, and at pi fourths, we also have an intercept. Whoa! Okay, it's surrounded by intercepts, which means we have an asymptote halfway between. Tangent is steadily increasing. So if this is at the midline, our point in between has to be above it, which would be at positive 2, our amplitude. If pi fourths is at the midline, the point before it needs to be below it because it's steadily increasing. So down 2 units. Fill out your wave, and you know how the rest goes. Just put little arrows at the end and you're fine. Okay, let's do the last one. We have our rise is plus or minus 1/2. B is negative 3 pi fourths. Sorry, C is negative 3 pi fourths. B is 1. B is the coefficient of theta. Okay, so B equals 1. C is negative 3 pi fourths. Phase shift is C over B, so negative 3 pi fourths over 1. And that's P1. That's your first point. The midline, no change. The period is pi over 1, which is pi. So if I want pi to have the denominator of 4, that would be 4 pi over 4. I'm going to add that to get P5. So P5 is the phase shift, the starting point, plus the duration, the period of one cycle. And that is positive pi fourths. So we're going from negative 3 pi fourths to positive pi fourths. They've cut it into fourths for us. That's quite convenient. Okay, let's find the average between those, but I think you'll find that between negative 3 and 1, you have negative 1. Let's show you. That is negative pi fourths. What's halfway between negative pi fourths and pi fourths? That's 0. What's halfway between negative 1 pi over 4 and negative 3 pi over 4? Well, that would be negative 2 pi over 4, which does reduce, but I'm going to keep it over 4. Well, I'm going to show you what the reduction is, but I'm still going to keep it over 4 in my graph. Okay, there's a little bit more in the negative section than the positive section. We're only going up 1/2, but I don't want to skew the graph too much, so I'm going to keep 1/2 kind of low. This one, negative 2. Okay. Pi fourths, and we need 4 of those sections. So 1, negative pi fourths, negative 2 pi fourths, and negative 3 pi fourths. Okay, cotangent P1 and P5 are asymptotes. P3 is an intercept. And cotangent is steadily decreasing. So the point that is before needs to be higher up, meaning 1/2. The point that's after the intercept needs to be lower down so that it's decreasing. Okay. So when A is a fraction, you see your wave kind of hugs closer to the x-axis for a longer amount of time. When A was 2, we shot up a little bit faster. It was kind of increasing at a faster rate. This one would be decreasing at a slower rate because of the gradual decline. Okay, that's tangent and cotangent. Have a great